Okay, good afternoon and welcome to a short, hopefully 20-minute overview of Scott Herr's version of what is systems thinking. First question we have to ask is, why do you care? In other words, what's the need for systems thinking? Those of us involved in this grant project feel that there's a need. What is it? Well, Einstein said we cannot solve problems using the same thinking we used when we created them. Therefore, maybe we need a new way of thinking or a new problem solving. I think it's better to use all the evidence when you're regarding historical behavior when you're trying to solve a problem, not just the most recent evidence. Systems thinking kind of helps us in that discipline. I also think, and to me what's really one of the more exciting parts, is that it provides a common language for discussing our problems, for looking at alternative solutions, and then the potential consequences of those actions. It's a way to run what-ifs on different potential solutions. First, to clarify, a food systems veterinarian is not just a person who works in the food system. Food system veterinarian is not a computer modeler, so you don't have to be able to play with Stella and at-risk and differential equations. They're not a mathematical geek. Definitely not a predictor of the future, nor is it someone who's just working on food safety. Both of those words begin with S, and people have a tendency to confuse systems and safety, but it's not exclusively food safety issues. A food system veterinarian or problem solver of any type, practitioner, is someone who's thinking with a special problem-solving mindset. They might be working in research, production, safety, policy, anything. As Peter Singy said, they're not taking the straight path from A to B. A food systems vet or practitioner is someone who's habitually using systems thinking, which we will explain. But first, let's think about what is thinking. Sometimes before I come home, my wife calls and tells me about one of my 7 sons and what they may have done wrong. You're not going to believe what so-and-so did today. So immediately I start thinking about how I'm going to handle it. And how do I think about it? Well, I role play. I think about scenarios. When I walk in the house, what's he going to be doing? How am I going to greet him? What I'm going to say? How it's going to go? And obviously those scenarios are simplifications. They only have the nitty-gritty details. I probably don't think about what he's wearing or what music's on in the background, that sort of thing. Therefore, it's a model, which obviously leads us to a commonly made statement by Deming that all models are wrong. Some are useful, and we do have to use them. We're going to use them whenever we think. We're going to do role playing. We're going to do what? Cause and effect. Well, if I say this versus if I say that, how might it go? That's what thinking is. Systems thinking, and Barry Richmond did a good job, I think, in boiling these down into 8 essential skills. You can find them, same skills, I think, framed in different vocabulary and other writings, but these are the ones we're going to use for our veterinary application today. First off, the 30,000 foot or the 10,000 meter view, where you ask what are the important external forces or inputs, and also what's the boundary of the problem that we're going to talk about today. We think about systems as a cause, or the system as a cause, where you look at the structural relationships. Operational thinking says, how is this thing supposed to work? How is it working? Closed loop thinking asks the question, what factors or drivers impact the input and output relationships that we're interested in? Dynamic thinking asks, what changes have or will happen as these processes continue? Nonlinear thinking says, how will the strength of these input-output relationships change over time? Scientific thinking says, show me the data. Let's test some hypotheses. And generic thinking says, what are the structure and functionalities that are similar to others? There tend to be a set of systems behaviors that can be found in a variety of different applications. And it's interesting, people who are really good at this can walk in and say, oh, that's a such and such sort of systems process.